Speaking of, ready for this one? Taking a bite and just the little tapas.
Oh.
You guys know where I'm going with this. NASA took a little tiny bite, just a little tiny sample of an asteroid. Asteroid Bennu. It happened, my friends. This is big news. This is the first time the United States has done it. And if this mission continues to go successfully, we'll learn more. I think as the recording of today, I think I'll learn more about how much they actually gathered from the asteroid. They'll be able to get accurate readings on how much the thing did. But here's a video from NASA for those.
Did they find coffee on there?
I don't know if there's any coffee. This, by the way, I should mention that we've retrieved very trace amounts, not we, but JAXA. Well, humanity, has retrieved very trace amounts of an asteroid with Hayabusa 1 about 10 years ago.
I couldn't remember the name of that. Thank you. Sorry.
How'd they get this angle?
The other one was CGI. This part is not CGI.
First they dropped a camera on the asteroid.
They threw a GoPro at it first.
James Cameron was up there with his submersible.
Whoa.
That'd actually be awesome if they would just put a GoPro down like first and just filmed it. Maybe next time, NASA. No, but this is really, really exciting. This was the OSIRIS-REx mission, Asteroid Bennu. And what it does is it's basically this tiny, little mosquito-like thing. And it goes down and
mosquito.
And by the way, it's been at Bennu. Let me think. When was that? 2017 that it got there? 2018?
Yeah, it's been there a while. I remember doing a video about it a long time ago on my channel.
That's right. It arrived at Bennu at the very end of 2018, December 31st, 2018. I remember it snuck into my an Astro Award that I did because it just barely made it in the year of 2018. But this is this is great news because first off, like it sat there and it mapped. That's why we have this beautiful image of the asteroid at the beginning of this video that I'm showing, because it has orbited for almost 2 years now and mapped out the asteroid with extreme detail, high resolution, extreme detail. And they're able to model it and find the best place to land, because the hardest thing about an asteroid is that its gravity is so low. You have to take into account its gravity, but dust flies everywhere. Like if you mess with it and stuff, it's just like this debris field. So going down and kissing it with this mosquito, basically it has like this mosquito nose, as that one little thing shows, and it kind of went down and it just sucked up a little bit of regolith, a little bit of dirt.
Yeah, but look at how much it just flies around. How much it scatters when they touch it. Do you happen to know, is it like a vacuum tube? Or is there like a drill on the end that kind of like messes it all up?
Yeah, I'll show you what it is. And I should mention that video was one shot every 1.25 seconds, I think. So the amount of time, it actually spent, I think 5 or 6 seconds on the surface. So this video makes it look like it just goes down and goes, and it just explodes and comes out. It was there for like 6 full seconds or something. So that video is very poor representation. But this is what the nose, the sucker thing looks like. It's actually a blower.
The proboscis.
What?
Thank you.
Excuse me.
SAT words.
But this is called the TAGSAM, which is the what's the background for that?
So Bennu is it now? It tagged Bennu and it's it now?
Yes.
And it has to chase another asteroid and make tag.
it. Thank you, Joe.
I'm 12.
Yeah, it tagged Bennu. But the way I'm trying to figure out what TAGSAM stands for. I saw it somewhere earlier. I don't know. Whatever. The thing
Touch and go, simple. Scroll up. There it was.
What?
A little bit more. Scroll up. Scroll up. Right. Touch and go, simple acquisition mechanism.
Sample acquisition.
Thank you.
I'm here for you, buddy.
Touch and go sample acquisition mechanism, TAGSAM. And what it actually is a blower. So they just shoot nitrogen out of the, imagine a Roomba, if you will, those of you listening, a Roomba. And in the very middle, it's about the same size as a Roomba. It's 1 foot wide.
Looks like a carburetor air filter or something like that. You know, like an old school.
Yes, it is basically that. So what it does is it laid it down onto the asteroid, basically, pushed it in a little bit, and then shot nitrogen, just inert gas, nitrogen from like a compressed bottle, shot it through the center. It disrupted dust and shoots it everywhere, or tries to shoot it everywhere, and it ends up getting collected basically in that filter. So here's a nice little video from NASA. if you guys, it'll be in the show notes, but if you want to see this video, it's under, if you type in OSIRIS-REx touch and go, they have this, NASA has this really good animation showing how this thing works. And yeah, it's awesome. The reason this is all exciting is not just because they're collecting the sample, but this sample will get shot back to Earth. So we will actually retrieve, humans will touch, probably with gloves, but will touch and actually get their hands on these samples from an asteroid. And that's why this is so important. It's not just like, Curiosity rover, awesome. All these other rovers that we've sent to, Mars and stuff like that. We're actually working on that with Perseverance, but all of those samples just stay. Yeah, look at this. They loaded up into this little tiny thing. Do you see that? It was a little arrow shell.
Mm-hmm.
Like that. And that capsule is what's going to re-enter the atmosphere, I assume. Yeah.
Yep. With some parachutes.
So does this whole? It's not a satellite. Does the whole spacecraft here return and then it just shoots that into the atmosphere, or does it shoot it off from where it's at now?
Oh, that's a good. I think it actually, if I remember right, does someone in Discord know? If I remember, I think it basically flies back. It what?
That would be a ton of delta V to get back to Earth from there.
Yeah, but it also has really efficient propulsion.
It'd be like a Dude Perfect video or something,
Because I think, yeah, if I remember right, it's ion propulsion. But all the guidance navigation is on this unit, the main OSIRIS-REx unit. So if I remember, I think it does basically fly back to Earth, get really close, and then it injects the thing into the atmosphere.
And it's probably going to swing around some planets and do some orbital stuff along the way.
Yep. Here we can read sample return on September 24th, 2023. The OSIRIS-REx return capsule will re-enter Earth's atmosphere and land in a parachute, but it doesn't say whether or not. Man, I don't remember. I don't think I've ever actually read how it actually returns back. But yeah, super, super cool. Huge congratulations to NASA for this. Again, so I mentioned Hayabusa. Hayabusa, I didn't realize when I read up on it that Hayabusa hadn't really retrieved the sample properly. They got very small trace bits of the asteroid, but they did not collect like a large sample size like they were hoping. So although this isn't necessarily a first, and as a matter of fact, Hayabusa 2, which landed on an asteroid, Ryugu, was that the one? Just only a couple years ago, 2-3 years ago, that is actually on its way back right now, and they'll be retrieving the sample. So this definitely isn't like a first to retrieve, asteroid samples. That doesn't mean it's not still something we need to celebrate. It's obviously the first time we've returned something from Asteroid Bennu. So that's just really exciting. And Hayabusa 2 is due back in December already. So yeah.
Oh, this year?
Of this year, yeah.
Like in a couple months. Okay, and so will that be the first asteroid sample from space that we have our hands on and collected?
Like the first real proper collection of it, since Hayabusa 1 technically had bits of an asteroid, but not, we're talking like a few particles of dust, basically,
So what was the satellite, what was the probe mission, whatever, that got behind a comet? And basically opened up a little gel thing and just took samples of comet dust.
Oh, geez.
I forget what that was, but they have done that.
I'm blanking right now. Yeah, that was the first comet retrieval, wasn't it?
The touch and go comet sample retriever, TAGSAM.
That one just kind of collected its farts.
Yeah. I think that sounds
some water
right.
bears, some tardigrades.
I am blanking on that one.
Rosetta?
No, Rosetta. Oh.
Where was it?
Wait. Gosh, it feels like it was like 10 years ago, and I have no idea. I think was it Rosetta and the little Philae lander. Remember that little lander?
Yeah, you're right. That was. God, there's actually so many that's kind of hard to keep track now.
That's exciting though.
What are we hoping to learn from these samples?
Well, asteroids and comets and stuff like that, they're very, they're relatively untouched. They don't have life like us, like teeming and messing things up. They're very stable. They don't have volcanic activity. So when you sample something like this, you're sampling bits of the early universe, basically, bits of stuff that could have been events from billions of years ago. and you just gain more data. That's what all of these sample type of stuff. We just have new benchmarks, new things to be able to compare our models of radioactive decay or whatever against other models. Just kind of plug in more data points to our understanding of things. Stardust mission, I forgot about that too.
Yeah, I was just looking on the Planetary Society's website.
Yeah. So yeah, I don't, it's one of those things I don't really know directly like what benefit this has to humanity as a whole immediately, but some of those things we don't really realize the fruits of that labor until, it gets in the hands of scientists and they all get to sit and parse through all the data, parse through all the chemistry, parse through all the geology, and actually, plug it in and do some work.
Figure out what's going on. Huh.
Yeah.
Well, and it's exciting because this is the unfiltered, unadulterated stuff that made up the solar system going back billions of years, and
you're kind of looking back in time.
Yeah. And I love the the footage where, they have the touch and go and the stuff scattered everywhere because the gravity is so low and whatnot. It kind of kills me. Like, these asteroids, they're just a very loose collection of dust and rocks.
Yeah.
Like, they are just barely held together.
Yeah. Yeah. You're right.
It's like
you even notice that it actually depresses into the asteroid. The nose does, just by gently coming down very slowly. That probe, the nose, is actually sinking into it because it's so loosely bound together. There's just not that strong of a gravitational field. There's not enough mass there. So it's just, like you said, loosely bound like rocks and dirt.
Now, that is one type of asteroid. There are others that are more solid, that are more rocky and like iron based and stuff,
and like diamond ones and stuff.
Yeah, because that's part of the promise, right? Or not the promise, but one dream is for construction in space. We would rather kind of lasso an asteroid with, I don't know how many tons of metal on it to make stuff with, rather than try to launch it from here.
Yes. Yep.
And then that would be...
And fuel, because some of them have, ice water. Some of them are literally made out of like platinum. Like there is what would be a really rare earth material or metal we could completely have 100,000 times the amount that we've ever seen on a single piece of rock in the sky, basically, or whatever,
Well, if I'm not mistaken, when the Earth was formed, some of the heaviest metal sank to the core, to the middle. So stuff that is kind of rare on the surface here is not so rare in space because there wasn't, it's not being stuffed down into the core of something.
That makes sense.
Yeah, so it's not easier to get because you have to actually hunt down an asteroid, but it's just out there.
Yeah.
It's probably easier to get than going to the core of the Earth, let's put it that way. Hey guys, thanks so much for watching this clip from our show. If that's just not enough for you and you want to watch the full episode, you can go to olfpod.com/YT.
And if you want more from us, you can consider becoming a Patreon member. You'll get early access to episodes. You can join our awesome community. You can actually watch us record live and get your name in the credits by going to olfpod.com/Patreon.
So thanks everyone for watching. Check back every Friday for new clips here and new episodes on the main channel.
Thanks everybody.